This is GCSEphysics Unit7 Motion Revision Podcast. Now, when we talk about motion, we talk about two different types of quantities, which we call scalars and vectors. So scalars are quantities which only have size. But vectors are quantities which have size and direction. And in this section in particular, you'll meet a few which seem very similar, but some of them are scalars and others are vectors. So one of the first examples of a scalar is distance. Distance is just a length. But then you have a kind of equivalent quantity, and it's called displacement. And displacement is a vector because it not only has a length, it also has a direction. So if you give someone directions to your house or directions somewhere, you're actually giving them displacements because you say, go out to the end of the road and turn right, and go for 2 miles along that road, turn left. So those are actually directions, but they're displacements. Another set of quantities which are fairly similar, but one's a scalar and the other's a vector, are speed, which is distance travelled in a certain time. And then its equivalent quantity is velocity. And velocity is a vector because not only does it have a size, it also has a direction. So it's really a speed in a certain direction. And we say it has a velocity of 4 meters per second west. Another one which doesn't really have a scalar definition or a scalar quantity is acceleration. And acceleration has a size and a direction. And we know a very good example of acceleration is acceleration due to gravity. And we always know that acceleration due to gravity acts downwards. Another one then is mass. Mass is a scalar, it just has a size, so many kilograms. And its equivalent quantity, which is a vector, is weight. And weight has a direction because it's an example of a force, and it always acts down towards the earth. So of course force is in here as well, and force is a vector because force has got a direction. So we always say we push forward or we pull backwards or we push downwards or so on. It always has a direction. A couple more there that might come in. Time. Time is a scalar, and maybe one more that you might know is, and meet in a different section, is momentum. But for this particular unit here that we are taping, it's really these ones here that that you should really know. Now the difference between distance and displacement, and there's a kind of an obvious difference, I suppose, in that if you have someone travelling to the right and they turn then and they travel back to the left again. So they go 10 metres to the right and 10 metres to the left. And there's their start position and finish position. Well, the total distance they've travelled is a total of 10 plus 10 gives you 20 metres. But their total displacement is 10 to the right, and then you have to take away 10 to the left. Their total displacement is 0. So that because they're right back where they started. So that's a very, maybe, odd one there. The other thing that you're sometimes asked about is your total displacement from your starting position in terms of having gone on a journey. So we'll give you a journey like this. Someone travels round like this. So they go 10 metres right, or we call it east, 10 metres east, 5 metres south, and 10 metres west again. And what is their final displacement from their starting position? So we calculate final displacement by going from the start to where they finished directly. And there's the finish. And where are they from where they started? They are now 5 metres south. So final displacement equals 5 metres south from where they started.